completion of study guide 5. We did this actually in class. And so this packet is probably something you have, maybe. If you don't, you can print it out. But we already did half of it. But we're going to need a calculator for this part that we're doing. So I'm going to quickly go to calculator. I forgot to get it. I'll be back. If you don't have a calculator, you can use Desmos. And I'll put that on there too. So, calculator. There we go. So, you can press pause, obviously, at any time. How do you change it from degrees to radians? And the answer is you multiply it by pi over 180. And if you want to, you can use your calculator or Desmos and just multiply it. I'd allow you to do that. So, 310 times pi over 180. That's what it would look like. 310 times pi over 180. So what fraction do you get? Is 31 pi over 18. How do I again do that? To change it to radians, I'm going to go pi over 180. So negative 155 times pi over 180. So again, this is what it would look like. And you get negative 31 pi over 36. 7 pi over 3. How do I go the other direction? So I multiply times 180 over pi. Notice the pi's would divide out. 7 times 180 divided by 3. So again, 7 times 180 divided by 3, and I get 420. Number 4, again, how do you change from radians to degrees? Times 180 over pi. Notice the pi's divide out, so I'm going to go negative 4 times 180 divided by 9. And I get negative 80 degrees. Easy peasy. All right, number 5. Can you state the quadrant in which the terminal side lies in? Then give the two co-terminal angles, one positive and one negative for each angle. So negative 285, what quadrant is that in? So I'm going to draw a little compass, and I'm going to go the negative direction. That's 0. That's negative pi over 2, negative pi, negative 3 pi over 2, and then back to negative 2 pi. So going in a clockwise direction. Oops, why did I do it in radians? Just to give a headache. How about 0 to negative 90, negative 180, negative 270 to negative 360? That's just silly. Why did it? My brain was in radians. Anyways, negative, 285. What quadrant are we in? We're up here in quadrant number 1. Going clockwise. Negative 3 pi over 5. Oh, and we also have to do the coterminal angles. So for negative 285, I would add 360 for a coterminal angle. If you add 360, use your calculator. 75 degrees. That's one that's coterminal. The other one is you subtract. So negative 285 subtract 360. And you get negative 645. So those are the two coterminal angles. All right, for radians, negative 3 pi over 5, I think it's easier to convert it first. So I'm going to go times 180 over pi. So that's 3 times 180 divided by 5. So that's negative 108. So what quadrant is negative 108 in? And it's over here in quadrant number 3. So I know it's in quadrant 3 because we're going clockwise. Next, for coterminal, we're going to keep it in radians. So I'm going to go negative 3 pi over 5 plus 2 pi. I'm just going to let the calculator do the work. So negative 3 pi over 5 plus 2 pi. So that's coterminal using radians. So one answer would be 7 pi over 5. And then the second one is I would subtract 2 pi. So 2 pi is the same as 360, just in radians. So negative 3 pi over 5, subtract 2 pi. And I get negative 13 pi over 5. Again, coterminal. All right, next. Write each angle. Now, degrees, minutes, seconds. We're not going to focus in on this at all. The next one has to do with arc length. We are going to do that one. So find the length of the arc. So I need to know what's the formula for that, and it's the radius times the angle in radians. So if I want to find arc length, the radius is 8.5, the angle is 5.55 or 6. It's already in radians, so all I got to do is type it in and go diamond enter. All right, so I'm going to do, so 8.5 times 5 pi over 6. Diamond enter. I get, it says round to the nearest tenth, so 1 decimal. So if I do that correctly, it's 22.3. And it's feet. Done. So again, can you find the arc length? So that arc, it's the radius is 6. The angle is in degrees. So how do I simply change it to radians for the formula? Go pi over 180, and that's it. So 6 times 120 pi over 180, diamond enter, and I get 12. And if I round it properly, it's 12.6, and it's inches. Done. Again, this is what it looks like. You can press pause if you want to, so you can match it with your calculator. All right, turn the page. 13. Can you find the area of a sector? So what's the formula for that? So it's 1/2 r squared theta. And again, that angle has to be in radians. So in this case, to find it, it's 1/2. The radius is 4.1. And then the angle is 2 pi over 3. So it's already in radians, so I just type away. And I'm going to use 0.5. So 0.5 times 4.1 squared times 2 pi over 3. And I get 17.6. And this one's going to be miles squared. So again, this is what it looks like on mine. 14. To find this area, it's 1/2. Again, the radius is 14, so I square it. The angle is in degrees, so I have to go pi over 180 to do the formula properly. So it's going to be 0.5 times 14 squared times 300 pi over 180. And that rounds to that, 513.1, and that is centimeters squared. All right, number 15. We're not going to do linear speed, angular speed, because we didn't talk about that in class. So I'm just going to go, nope, nope, nope. That's okay, right, with you? Number 19. Let's keep going down here. Hey, do you know how to find a missing side using trigonometry? These are questions involving so, ka, toa. Maybe I'll put a link for the song. So, for so, ka, toa here, circle the angle. 23 is the opposite side, and what I'm looking for is the adjacent. So of these, which one uses opposite and adjacent? So that's tangent 64, and we do the ratio of 23 over x. To get x by itself, I multiply by x and then divide, and then use your calculator. So it's 23 divided by tangent 64. I'm going to remind you of something important. That when we do this, do you remember the bottom of the calculator or the screen? See how mine says DEG, right? If yours says RAD, it's in radians. You have to press what's called the mode button down here. And when you press mode, you'll see this pop up that you need to have the skill to go down to angle, arrow to the right, and then select degree and press enter twice so that it's in degrees to get the right answer. So the right answer is 47. What do we want to round it to? Tenths, so 47.2. And there's no units, so it's just 47.2. All right, number 20. I'm looking for an angle. So what I know is 37 is the hypotenuse, 24 is the adjacent side. Which one uses adjacent and hypotenuse? So that's cosine. And because I'm finding a missing angle, it's inverse cosine. And the ratio is 24 over 37. So press the yellow button, diamond. So press diamond, cosine. So it has that little -1 to it. And then put in the ratio. So whenever you find a missing angle, you're going to use inverse, that little -1, to find the missing angle. So it's 49.6. Number 21. Angle, opposite, and hypotenuse. So which one uses opposite and hypotenuse? That's sine. So sine 22 is equal to x over 19. To get x by itself, multiply by 19. So if I multiply by 19, I'm going 19 times sine 22. And I get the answer 7.1. All right, next page. Some stories. So a 30-foot ladder is leaning against a building. There's my ladder. If the base of the ladder is 17 feet from the base of the building, or the base of the ladder is 17 feet from the base of the ladder is 17 feet from the base of the ladder, I think they mean the base of the building. I'll rewrite this so it makes sense. Find the angle of depression. So the angle of depression is the angle looking down. So the angle I actually want, to begin with actually, it's this angle here, but it's not. We're going to find that angle, but the angle of depression is actually the one made with a horizontal. So it's actually this one. So when we find this angle, I need to subtract 90 for the angle of depression because it needs to be with the horizontal. So if I want to find that angle, what would I use? Opposite and hypotenuse. So it's inverse sine. So it's 17 over 30. Use that. And then whatever answer that is, I'm going to subtract 90. So inverse sine, 17 over 30. So I get the angle 34.5. But the angle I really need is the one on the outside of the triangle. That's the angle of depression. So subtract 90. And you get 55.5. And that's the angle of depression. Number 23. Sharon is bird watching and spots an eagle in a tree while standing 40 meters from the base of the tree. The angle elevation is 37 degrees and 27 minutes. We'll do that in a second. After moving closer to the tree, she now measures the angle as 51 degrees and 42 minutes. Angle of elevation. Determine the distance Sharon traveled between the viewings. So I got Sharon right here, and she's viewing a bird in a tree. And the first thing she noticed is that the angle of elevation there to where the bird is 37 degrees. Now, 42 minutes. To find the decimal, we just go 42 divided by 60. So 42 minutes is how much of an hour? So the decimal would be 0.7. So this is 37.7 degrees. Then she brought closer. And again measured the height there, but this time since she was closer, there was a bigger angle of 51 degrees. Again, 42, wait a second, 42 was for the 51. The other one was 27, so I need to go 27 divided by 60. Sorry about that. That's 0.45. So this should be 0.45. That means this is 0.7. And the answer is, what's the distance Sharon traveled between the viewings? So this right here, this is what I'm looking for. So I don't need right triangle trigonometry. I'm actually going to use the law of sines here. So what I need is a side that I know, or maybe I do need to know this. So do I know any actual, when she's standing 40 meters from the base? So this whole distance here is 40. So I am going to use right triangle because that that full distance is 40, I'm going to find the hypotenuse to begin with. So if I have an angle and this is the adjacent side and hypotenuse, I'm going to use cosine. So cosine of 37.45 is equal to the adjacent side over the hypotenuse. I'll call that y. So then when I multiply and divide, I'm going to go 40 divided by cosine 37.45. So let's see approximately how long that hypotenuse is. So 40 divided by cosine 37.45. And I get the hypotenuse to be 50.4 about. I'll use that number, it's fine. And then if this is 50.4, now I'm going to use the law of sine. So what angle is here on the other side? So I need to go 180, subtract 51.7, they're supplementary. So the angle on the other side must be 128.3. So if that's true, I'm going to go sine 128.3 over 50.4. And then to find this one, I need to know this angle up here. So to do that, I'm going to go 180 subtract 128.3 subtract 37.45. So I'm going to subtract these two angles. And then the little angle up here they found is 14.25. So it's sine 14.25 over what I'm looking for, x. So to get x by itself, I'm going to multiply. So I'm going to multiply 50.4 times sine 14.25, and then I'm going to divide by sine 128.3. And that's it. So let's put that in the calculator. 50.4 sine 14.25 divided by sine 128.3. Make sure I typed it in correctly. And the distance you traveled was 15.8, and that's in meters. All right, I think that's everything. So you can see what we've already done here below. Let me see if there's any empty questions. Oh, there are some empty questions here. Let's do this. All right, number 34. This is the law of cosines. Can you solve the triangle below using the law of cosines? So to do the law of cosines, first of all, if I want to find j, here it is, I go inverse cosine, and then this is going to be the angle for j. What side is opposite of it? 21, subtract. Now the other side, the order does not matter. And then negative 2 is part of the formula, and then 24 and 11 needs to be belonging in the denominator. So understand the structure and template of that. All right, so when I type this in, I make sure I start with 2 parentheses. See the 2? Then start typing. So 21 squared, subtract 24 squared, subtract 11 squared, and then close it. So you see how I did that? And then divided by, open up another parentheses after you divide. Then in the denominator is negative 2 times 24 times 11, and then close it twice. And then go diamond enter, and the angle is 61. Now, I have to do it again. So if I want k, again, how would you set it up? So see if you could set it up for k, and then use your calculator. So see if you set it up the same way I did. Again, when you go inverse cosine, 2 parentheses, 11 squared, subtract 24 squared, subtract 21 squared, and then the denominator is negative 2 times 24 times 21. Close it twice. So make sure you're typing it in correctly. When you do the parentheses correctly, take your time. That's what the picture looks like, and there's your answer, 27.3. Now, once I have that, I can then just go 180 subtract. So I'm going to go 180 subtract 61 subtract 27.3. So this last angle is 91.7. All right, for this one, we're not asked to solve everything, just to find one thing in particular. So in this case, I just need to find AC. So I'll put x there. Notice it's side angle side, so it is the law of cosine. So we're going to start with a big square root sign. Pick a side, that's 8. Pick another side, that's 9. Subtract 2 is part of the formula, 8 times 9, and then the cosine of the angle in between them, which is 76. So start with the square root sign. 8 squared plus 9 squared. Subtract 2 times 8 times 9, and the cosine of 76. Close it twice at the end. See if yours matches mine. So press pause and look at your calculator. Make sure you're writing it correctly. So it's 10.5. Number 36. In triangle DEF, why not? DEF. Angle E is 47. DE is 17. There it is. EF is 16. Done. And then find angle F. Now, to find a missing angle using law of cosines, you need to know all three sides first. So I have to solve for that first. So big square root. 17 squared plus 16 squared. Subtract 2 times 17 and 16, and then the cosine of 47. So type that in. Again, you can press pause at any time if it's going too fast. So 17 squared plus 16 squared. Subtract 2 times 17 and 16, and the cosine of 47. So that's what mine looks like. So it's 13.2. Now I'm going to use that then to find this angle. So if I want to find the measure of angle F, it's inverse cosine, big fraction, and then I have to write down, first of all, what's opposite of F? 17, and then the other sides, which are 16 and 13.2, and then the denominator is -2 and 13.2. So type this in. So inverse cosine, 2 parentheses, 17 squared, subtract 16 squared, subtract 13.2 squared, close it, divide, open up another parentheses, -2 times 16 times 13.2, close it twice, diamond enter, and you get 70.5. So 70.5, and that's it. Is it meters? Meters. Oh no, that's angle, right? So that's 70.5 degrees. Sorry. This is meters. So angle F is 70.5. Again, this is what it looks like. Make sure you're typing it in correctly. All right, number 37. A story. The log ride at an amusement park has a giant hill. The ride inclines with an angle elevation of 33 degrees over a horizontal distance of 50 feet. So the horizontal distance, is 50 feet, and it rises at an angle of 33 degrees. The angle of depression of the decline is 54 degrees over a distance of 42. Find the length of the ride. So this is my understanding of it. So now the horizontal distance is 42 feet, and so the angle of depression, which is the one outside the triangle, is 54. So to find what's inside, I'm just going to go 90, subtract that. If I can do that, it's 36 here. I can also do parallel lines and understand this angle here is also 54. They add up to 90. Here's a 90, here's a 90. I could also do this angle up here. That's not 57, because they add up to 90 to make that. So I already know all kinds of great angles in there. And then I'm asked, what's the length of the ride? So I need to find x, I need to find y, and then add it all up. So I'm just going to use SOHCAHTOA to do this. Right triangle. So if I want to find x, how long it went up, I'm going to use these two, this angle and adjacent. So adjacent and hypotenuse, that's cosine. So I'm going to write down cosine of 33 is equal to adjacent over hypotenuse. To get x by itself, we multiply and then divide. So there's one side. You get your answer. So 50 divided by cosine 33. So that's 59.6. To find y, it's the same setup. It's cosine of 54 degrees this time. And this time it's 42 over y. So to get y by itself, I would multiply and then divide. So it's 42 divided by cosine 54. That's a 4. So 42 divided by cosine 54. That's 71.5 if I round it correctly. And then add those two up. And the total length of the ride is 131.1 feet. And you have your answer. All right, number 38. Two towers at a national park spot forest fire. Tower A spots the fire at a bearing of 38 degrees north and then west. So if I think of this in terms of there's Tower A, if you go north and then west 38 degrees is where you would end up. And that's 38 degrees there. And Tower B spots the fire at a bearing of north and 48 degrees east. So I'm going to think of this as Tower A and Tower B. I'm going to go north, and then how many degrees east? 48. So this here would be 48. And then the matter is, if the tower is A is 729 meters tall, and directly east of Tower B, find the distance from each tower to the fire. So let's just try one at a time. First of all, to find the angle inside, I'm going to go 180 subtract. So I'm going to go 180 subtract 48 subtract 38. That's 94 in here. I'm also going to find this distance here using that number. So if I want to find this distance, how far A is from this fire right here, I'm going to use right triangle trigonometry. So what angle do I know, what side, and what am I looking for? So I'm looking for the hypotenuse. And I have opposite and hypotenuse there. So it's sine, wait a second, that 38 is right in here. So I have adjacent, so adjacent to that is 38 degrees. And it's 729 over x, which is the hypotenuse. So multiply and then divide. So it's 729 divided by cosine 38. So Tower A is 925.1 meters from the fire. I also want to find the other side. So now that I know what this is, what else do I know? Let's see. So I now know these two. So I now know a side in here. I know an angle. Do I know another angle? I do. So another angle in here would be, this angle in here would also be 48 using parallel lines. And so if I have angle, angle, side, I can use law of sines. So that's what I'm going to do. So sine 48 over what I just found, 925.1 is equal to, I want to find this other side. I'll call that y. On this side right here, how far it is, what angle is there. So again, if I do parallel lines or go 180 subtract, I see that angle's 38. So it's sine 38 over what I'm looking for, which is y. So to get y by itself, I'm going to multiply. So 925.1 times sine 38, then I'm going to divide by sine 48. So 925.1 sine 38 divided by sine 48. So how far is tower B? And the answer would be 766.4. I know, but you know what? We did it together, right? You didn't do that by yourself. All right, turn the page. We just have 2 more questions to do. All right, number 39. Find the area of the triangle below. So what I see here is this is 15 and 15. That means it's isosceles. That means this angle is also 39. And the importance of that is I need the angle in between the sides to find the area. So I'm going to go 180, subtract 39, and that's 102 up here. So because it's isosceles, I was able to find the angle I'm looking for. Now I need to know the formula. So the formula is 1/2 times the side, so 15 and 15, times the sine of the angle in between them, which is 102. So 1/2 times 15 squared times the sine of 102. So that's 110.0, or just 110. So approximately, what's the area? It's about 110 millimeters squared. All right, a triangular plaque has side lengths of 8, 13, and 15. That is Heron's law. Find the area of the plaque. So Heron's law says first, if you know all 3 sides, add them. 8 plus 13 plus 15 and divide it by 2. So use your calculator, but be careful. You need to add, press enter, and then divide by 2 so order of operations is right. Or you can just add them. 21 and 15, that's 36, and divide by 2. So altogether that's 18. Next, the formula, you'll need a calculator here. The square root, we start with 18 and just subtract one side at a time. So square root 18, 18 subtract 8, 18 subtract 13, 18 subtract 15. And that's 51.96, or just round it to 52, and that's inches squared. All right, awesome reviewing trigonometry. Mr. G Math, I'm over and out. Good job.